All right, starting off on number 1 here, it's asking for me how many 3-digit numbers can be formed with these digits if repetitions are allowed and are not allowed. So I'm doing a 3-digit number, so I always kind of show these by doing lines here, and we kind of always, for these types of questions, multiply the possibilities together. And so if repetitions are not allowed here, I kind of put above the lines how many possibilities we have here. So there are 5 different numbers I could put in this position. But since I'm not allowed to repeat, that number drops down to 4 because whatever number I put first, I'm not allowed to use again. And then, so this one drops down to 3 then. So I can just multiply those in the calculator, and I get 60. Now, if repetitions are allowed, that means that these are just all going to be 5 because even if I use kind of a number in the first spot, I can still use that number in the second spot. So I still have 5 possibilities at every turn. So that's going to be 125. All right, next up here, we can create numbers with these digits, and it says repetitions are not allowed. And then it's asking us how many 1-digit numbers can we do. Well, for that, we could only do 4 1-digit numbers. We could do 4, we could do 6, we could do 7, or we could do 9. So again, I'm not putting the number 4 there as in it's going to be a 4. I'm saying we have 4 possibilities there, so that's a 4. So then for 2-digit numbers, I have 4 possibilities for the first one, and then actually only 3 possibilities for the second one because it says it's not allowed, so that's going to be 12. For 3-digit numbers, I have 4 possibilities for the first one, 3 for the second one, and then 2 for the third one. The possibilities keep dropping by 1 because as I use numbers, I'm not allowed to use them again. So that is going to be 24. And then 1, 2, 3, 4-digit numbers here. And so that one I have 4 times 3 times 2 times 1. So it's actually going to be the same as the previous. And once again, just those numbers keep decreasing because repetitions are not allowed. Now for the number with any digits, well, really that's just going to be the sum of all the previous ones because in this last one it's saying I don't know if it's a 1-digit number, a 2-digit number, or whatever. So I can just add all those up. So it'll be 48 plus 16. And that'll be 64. All right, this one is saying we have 8 basketball teams in a tournament. Find the number of different ways that first, second, and third place can be decided if no ties are allowed. So I'm going for first place and second place and third place are the things I'm trying to decide on. And then how many options do I have? Well, for first place, 8 teams could get first place. However, the same team can't get first and second place. So once I have who's first place, I only have 7 possibilities for second place and then 6 possibilities for third place. So 8 times 7 times 6 is 336. All right, next up, it says a girl has 8 skirts, 4 blouses, and 6 sweaters. How many different combinations can she wear? So we're going to have to make 3 decisions here. The skirt and the blouse and the sweater. And so how many possibilities do I have? Well, I have 8 skirts, 4 blouses, and 6 sweaters. So that we just multiply all those together. That's going to be 192. Question 5 is asking how many ways can 8 people sit in a row. So it's kind of assuming that this row has 8 seats. And so how many people can sit in the first seat? Well, there would be 8. And then you can't sit in 2 seats at once, so this would be decreased to 7, and then 6, 5, 4, 3, 2. Oh, and I did need one more there. Not that that one really matters because it's just multiplying by 1, but we want to show that last seat there. So we'll just multiply all those together. And that's 40320. All right, next up here is how many 7-digit phone numbers can be formed with all of these digits if the first digit may not be 0. So there are 10 digits possible here, but since the first one may not be 0, that's only 9 options for the first number. And then we have 6 more numbers. And I would say for all of those, we have 10. It doesn't say that we can't repeat. I see a lot of phone numbers where numbers are repeated, so I'm going to assume that means that we can repeat these numbers. And so then we'll multiply all those together, and that's going to give us 9 million. All right, this person knows the 4 digits that are in his 4-digit access code for the ATM machine, but he forgot the order. So how many times would he have to try to obtain the correct code? So we do know that it's a 4-digit access code, so I'm going to draw 4 lines. And there are 4 possibilities for the first one. And then it says that all 4 of them must be used, so that means that we're not going to be repeating, so that's going to drop to 3 and then 2 and then 1. And once again, these aren't the actual numbers, these are just how many possibilities we have in each spot. And so that actually comes out to 24, so we'd only need to try 24 times. All right, next up here it says that we have a recursively defined sequence. So I'm going to kind of try to interpret this. Well, actually, I already know that A1 and A2 are 7 and 6 respectively because it literally tells that to me. So then the next thing I need to figure out is how this sequence moves forward. So if I interpret this as A sub 3 out front, then this one right here, 3 minus 1 in the subscript, would be A sub 2. And then this one here, 3 minus 2 in the subscript, would be A sub 1. And so what it's saying then is that any term is the previous 2 terms added together. So A sub 3 is going to be 13. So now A sub 4 is going to be the previous 2 terms added together, but now that's A sub 3 plus A sub 2. So that would be 6 plus 13, which is 19. And then for A sub 5, it's going to be the previous 2 terms added together. So A sub 3 plus A sub 4. I think I did that in the wrong order, but it doesn't really matter because I got the right 2 terms there. So 13 plus 19 is going to be 32. All right, this one they want us to write in sigma notation. I know that since that says 1, this one is A sub 1. And so I'm going to try to see what the pattern is. So it looks like consistently adding 6. So that tells me that it is arithmetic because that's consistent adding or subtracting. And it tells me that D equals 6. And so I'm going to say A sub n equals 6n. And since it's plus A sub 0 back here, but since I know that that first term is really A sub 1, it would actually be, my A sub 0 would be minus 1, since I have to kind of subtract 6 to go backwards. So I know my formula then is 6n minus 1. So my last piece is I need to figure out is how many terms we have here. So I really need to figure out what term is that last term. I definitely do not put a 59 up there. What I need to do is plug 59 into my equation and figure out what n that gives me. So then it says 60 equals 6n. And so n equals 10. So that's the 10th term. All right, next up here, I see another one they want me to write in sigma notation. So I notice here that we're starting off at 0. So this is A sub 0. And so if I actually I'm going to rewrite this down here. I do notice that the x keeps staying the same and the the exponent keeps changing. And I notice that this is actually 1. If you think about it there, that's the first power. And actually, I'm going to rewrite this one as x to the 0 power because anything to the 0 power is 1. So with that, I would say that my formula here is x to the power of k. I notice that I'm plugging in here a k value in for the exponent, and we don't plug that k value in for x. So that's why I put the k up there while leaving this as an x. So those x's stay in my summation, but the k's turn into whatever term we're talking about. So I think it's pretty clear to see which one we're stopping at. We're stopping at 84. Not that that last term is 84, but when I plug in 84, I get that last term. All right, next up here, they're asking me if this is geometric, and if so, what's the R? So those questions are very much connected. I need to check and see if A2 over A1 is the same as A3 over A2, kind of etc. So if I do check this out, A2 e to the 10th over e to the 5th, we need to remember that our exponent rules there for division means we subtract these. So that's going to be e to the 5th power. And so for A3 over A2, that would be e to the 15th over e to the 10th, which is also e to the 5th power. And for A4 over A3, that would be e to the 20th over e to the 15th, which again, we subtract those, and that's e to the 5th power. So that is all the same. And so I would say, yes, this is geometric, and the R is e to the 5th power. All right, next up here, it actually says that this one is geometric, and so I'm going to assume it is, but we still need to check R here. So R is any term divided by the term in front of it. So in this case, I'm going to say 4 to the 5/3 power over 4 to the, and this is really the first power, but since I know I'm going to need to subtract this, I'm going to say the 3/3 power. And so if I kind of figure that out and I subtract the exponents, it's going to be 4 to the 2/3 power as our r. So I'm going to, and that equals r. So I can put that right here, 4 to the power of 2/3. So now to figure out a sub 5, actually I would do a sub n next. So a sub n I know is going to be a sub 1 times r, and then to the power of n minus 1. So that's what I'm going to put there. You actually can simplify that a lot, but you actually don't need to in this question. I'm just going to leave it like that. So now when I want a sub 5, that's going to be 4 times 4 to the power of 2/3 to the power of 5 minus 1, which is 4. Now we do need to remember that these two fractions multiply, not that because they're fractions, but because we have power to a power, they multiply. So that's going to be 4 times 4 to the power of 8/3. And then I have the same base here multiplying, which actually means we add these exponents. And I need to remember that this exponent's really a 1, so we can add them together. But I would actually then write it as a 3/3, just so I have a common denominator here. And so that gives me 4 to the power of 11/3. So that's what I would put right there. It says 11/3. 4 to the power of 11/3. All right, next up here, we want to find the infinite geometric sum. Awesome. So we are going to do, our formula here is a1 over 1 minus r for the infinite sum. But remember that this only works if r is between -1 and 1. If it's not in between -1 and 1, it is what we call divergent. And we cannot find the sum. There is no sum. So let's check this one out. So I see that a1 is obviously 1. And then r is a2 over a1, which is 1/4. So we are in kind of the good zone here for r. So we can use this. So it's going to be 1 over 1 minus 1/4. So I'm going to change that to 4/4 for a common denominator. 1 over 3/4. Multiply by the reciprocal. 4/3 times 1 is just 4/3. All right, next up here, same idea. Once again, I would check r to see if it's between -1 and 1. If not, it's divergent. So it'll be -1/3 over 1, which is -1/3, which is certainly in between -1 and 1. So we're going to say the sum equals a1 over 1 minus r. Now notice here that r is negative, so we're actually going to go plus here. So that's going to be 4/3 on bottom and 1 on top. So that's going to come out to 3/4. All right, next up here it says the construction company but purchases the bulldozer for this much. It says let n equals 1 be the year and the bulldozer was purchased, so that means that this is my a sub 1. And then it depreciates by 20%. Now that's a decrease, a comparison to last year. So whenever that happens, you need to add or subtract that number from 1. So since this is depreciating, I'm going to subtract it from 1. So this comes out to 0.8. So then I could say this is a sub 1, 195,000 times 0.8 to the power of n minus 1, and I have to have that n minus 1 there since I'm starting with a1 here. A couple ways we could do part B of this. We could take our formula and plug that in, but I would just we're going to have to use logs if we do that, so I think what I would do is I would just start kind of plugging in some numbers and seeing what happens. And actually, I'm just going to do that in my calculator. So let's find a sub 2. It's actually v sub 2, but I don't really care. So that's going to be 156,000, okay? And then a sub 3 would be 124,800. A sub 4 would be 99840, so that is it. So I'm going to put 4 right there. All right, next up here, it says we have an initial bacteria of 7,000, and then it increases by 4% every hour. I'm actually going to write my formula first. I'm going to do this kind of backwards. So if it's increasing there, then once again, we're going to compare that to 1 for our r. So it's going to be 1 plus 0.04 or 1.04. The 1 kind of keeps it the same, and then the plus 0.04 increases it by 4%. Initial, that to me always means a sub 0. That's after 0 hours. So I'm going to say that this is 7,000 times 1.04 to the power of n. So then when I need this to the 9th power, I'm going to do 7,000 times 1.04 to the power of 9. And that gives me, it says round to the nearest whole number, so I'm going to say 9963.